Hi everyone, welcome back to Workshop, and it's project time again, and another conversion to TFT LCD, and this time on my HP3457A. Now again, I don't claim that this is all my own work, because the actual display protocol was reverse engineered by somebody else on the EEV blog forums. And I just read through that really magnificent post and managed to work out how to implement it on my Blue Pill STM32 board, and of course drive my own TFT LCD. But what's wrong with the original LCD? Because there is no VFD in this unit, there is no vacuum fluorescent display, it's actually an LCD already. But what's wrong with it? Well, let me switch it on and let's take a look. But before I start, a shout out to all the new faces tuning in right now. You make up over 60% of the views lately, which is awesome. If you're liking my content, please subscribe so you don't miss the next one, and turn on notifications too. For everyone, including my regular viewers, don't forget to like my videos, as it really helps my channel grow. Now of course the camera's not straight on to the actual unit, but let me just power it up. And you can see the standard LCD doesn't have backlighting, so it's actually quite hard to see it. The original LCD that's used is not a particularly high contrast unit, and that's why some of the folks on the EEV blog forums have been taking that display protocol and they've managed to implement their own display. Some of them have done LEDs and that sort of thing. But because I've already got a TFT LCD method that I've used on the R6581T multimeter and my last video, the ADCMT 6243 DC voltage current source, I thought I'd implement that same hardware. Now, for the purposes of my own testing and development, I actually tied in to this IC here. I'll bring up the schematic showing that tie-in points. There is actually 5 digital lines that need to be picked up, as well as power 5 volts, and this cable here goes away off to my Blue Pill board. The HP3457A display uses a synchronous serial protocol with 5 signals, a clock called O2, a chip select called PWO, a sync line, and 2 data lines called ISA and INA. On every rising edge of the O2 clock, the display samples either ISA or INA depending on the sync line. When the sync line is high, the data on ISA represents a 10-bit instruction. When sync is low, the data on INA represents payload data following that instruction. Each transmission starts with 2 dummy 0 bits. That caught me out for a while. Then the real data is sent least significant first in groups of 8 bits. Instructions tell the display what's coming next, for example, writing register A, B or C, or updating annunciators. The actual characters on the screen are reconstructed from the 3 registers. Register A provides the lower segment bits, Register B provides the upper segment bits and punctuation, and Register C provides extended segment information. Combining those 3 gives the final character for each digit. Annunciators are much simpler. They're sent as individual bits after a specific instruction, 1 bit per annunciator. So my STM32 passively listens to the bus, decodes the instructions and data in real time, reconstructs the characters, and redraws the display on the TFT. On the actual STM32 side, everything's driven by interrupts. The O2 clock is connected to an interrupt input, so every rising edge triggers an interrupt and samples the bus at exactly the right moment. This guarantees correct timing without polling or delays. The interrupt handler reads the sync line to decide whether it's currently receiving an instruction or data, as I mentioned earlier. Shifts incoming bits into a small state machine and assembles complete bytes and commands in real time. And because the STM32 only listens and never drives the bus, the original HP hardware runs completely unmodified. The microcontroller simply decodes the traffic and updates a TFT display in the background. Now, I do actually have another front panel here which I can use for demonstration. The LCD module, the original one, is held in with 2 screws. So actually I've got those screws removed at the moment, so I can just lift out the original LCD, and there it is there. And the connection to the motherboard in the 3457A is by way of this ribbon cable here. But before I disconnect it, let me just put it back for a second. There we go. It's not in properly, but it'll do. And let me bring in my TFT. Now there is the blue pill board and the TFT driver board, and there's my LCD. I've actually got it stuck to the back of a carrier, the same carrier that's used in the 3457A, but this is the LCD here, a much smaller one than I used before, and this one here is the right height for the 3457A, albeit it's slightly shorter. So let me power it up and I'll show you what the TFT looks like. Let's power up. And there it is, fully working. Now as you'll notice, the annunciators, I've implemented them same way I did it on the R6581T. I've actually put the text onto the actual LCD itself. On the original 3457A, the indicators are actually annotated along the front panel here, and there's just an arrow that flashes there, a down arrow that flashes whenever any one of these annunciators is on. But I didn't want to do it that way, number one, because the LCD here isn't long enough to cover from this one here all the way to the end. So I had no choice really but to do it a different way. And if I just turn the power off and on again, you'll see the splash screen appears and all the annunciators are lit. There they go there. Now one benefit of my TFT here is I can actually display more characters than in the original LCD. If I just increase the number of digits, there we go. You can see on the original one there's no space. There wasn't enough room on the original LCD to have a space between the units and the last digit there. And on my TFT you can see that I do. I actually had 2 more characters of space, so I made use of that. And the other thing I've done is the units, I've actually corrected them. On the original LCD there was no such thing as lowercase text, so millivolts DC had to have the uppercase M. Of course I've managed to fix that on my TFT, and the same goes for all the other units as well. But the question is how to mount this TFT onto the 3457A. Well, on my test setup I just used a spare carrier from an old display panel that I had in order just to mount it, but on the final unit I'm not actually going to do it that way. So let me disconnect this LCD here, get it onto the workbench, and I'll show you what I've done. So here's my spare 3457A front panel, and I'm going to use this to demonstrate how the original LCD was mounted and how my new board and TFT are going to be mounted. So the LCD module that comes with the 3457A is basically just laid in here and screwed in with 2 self-tappers here. But also right at the front is this little transparent window to keep prying fingers away from the actual LCD. And from there the ribbon cable just plugs in to the dual inline holes on the back of the LCD. Pretty simple. So how's my TFT going to be mounted? Well, we don't need this for a start. Okay, the clear panel goes in first as before, and then I've got this laser cut black 1mm acrylic panel that will go in next. And you'll notice it's got a notch out at this end, and the reason for that is, for some reason, there's a raised part on the back of this panel here. Not sure if you can see that there. And it's only at one end. I'm not sure what that's for. It doesn't seem to serve any purpose, but I can't put the black acrylic panel directly on top of that, otherwise it'll be raised up. So that's why I've got the notch at the end. But why do I need this black plastic panel? And the reason for that is, when you look at the TFT panel itself, you can see you've got this at the end here. Even with the ribbon folded flat, it's not completely black there, so you would see that through the window. So what I've done is I've laser cut my own panel that's just under the size of the actual TFT black window there, as you can see. And that'll go in just like that there. And when you look at it from the front, you'll see that it's just completely black. Perfect. And then the PCB needs to go on top. Now, this is my PCB, a nice paper cutout of it, as I'm still waiting on it arriving. And there's got a hole at the end here where the ribbon cable just goes down through there, and then the PCB is actually secured using the same mounting holes as the original LCD module. And then from there, the TFT driver board will go down onto there, the ribbon cable will just flip down and into the socket at the end, and of course the STM32 will just go right there. And then the ribbon cable that connects to the module, I've duplicated the exact same pin out there, so the ribbon cable can just plug into those holes there. But of course there's one other problem. What's to stop this TFT LCD from moving around? Well, there's a couple of different ways around that. You could use some double-sided tape, the little 2mm stuff that I used in the previous TFT build, right around the edge there, or top and bottom, and then basically stick it down onto the back of that black plastic panel. But I don't think I'm going to do it that way this time. I'm actually going to use some of this single-sided thick foam, and I'm going to stick a length of it onto the back of the TFT, and then the PCB will compress down onto it. Hopefully anyway. But we'll see when we've got the actual PCB and I do the actual build. But first things first, take a look at this window here. It's not only rather grubby, but if you look through it, it's kind of a bit hazy looking when you look through it. And I've got two of these 3457A panels like this, and they're both the same. So I'm not sure if they're like that from the factory in order to somewhat diffuse the LCD readout. I'm not really sure, but we can't have that with a TFT, so I need to come up with a way of cleaning that up. And what I've got is this plastic and acrylic polishing compound, and I've used this before and it works pretty good, so let's give it a bash on the window. And the other side. Right, let's give it a clean up and see what it looks like. Well, there's a first pass and it's looking rather clear. Could still do with a Couple of bits of cleaning up around about there. We've got some red paint or something like that. So I might need to use some IPA or something to take that off. But I think that'll do the nicely. Okay, and there's my prototype board all fully assembled. You can see you've got the hole at the end where the flat flex is going to come up through and onto the connector. Blue pill, a couple of capacitors, and of course the header here, which takes the signals from the main board inside the 3457A. I've also mounted the TFT onto the back of the acrylic that I laser cut. I'll use Kapton tape. It's not required to hold it in place once it's all fully assembled. It's just to stop it moving around when I put the thing together. And of course, here is the window that I've fully cleaned up, and it's looking pretty good. So let's get everything into the 3457A and see if it works. But before I actually fit it, I do want to double check the connections here are all correct and in the right order down through this ribbon connector here down onto the main board. So what I'm going to do is I'm just going to plug this in here with power off, obviously, and then use my multimeter from end to end, and let's see if it's all correct. And I've got a table here which I've annotated onto the blue pill diagram to help me out. Okay, I've managed to get the board sitting vertically there so that I can actually get onto it no problem. So first of all, PB15 should go to pin 9 of U611. So PB15 is there, and that should go to pin 9. Yep, perfect. PB14 should go to P15. 14 is there to pin 15, 10, 11, 12, 13, 14, oh, 15. Yep, perfect. PB11 to pin 12. So PB11's over at this side to pin 12. Yep. PB1 goes to pin 6. However, that goes through a resistor divider here in order to take the 5.5 down to around about 3.3. So PB1, which is there, should measure 4.7K down at pin 6. Well, I'm getting 3K. There's obviously other resistances on the board. They are affecting that, but I'll take that as okay. And lastly, PB12 should go to pin 2. So PB12's right up the top here. Should go to pin 2. Yep, perfect. And the supply, so let's check 0 volts there. Should go to there. Yep. And the 5 volts, that's not working, but I know the reason for that. I'll bring up on screen here the schematic for the 3457A. Now, as you can see, there's a resistor on the main board there, a series resistor going off to the original display. So I do actually need to bypass that resistor in order to get 5 volts from the main board up into this board to power the blue pill. And there we go, a little bit of Kynar, bypassing that resistor, no problem. So I should get 5 volts on the blue pill right down onto the main board. We'll just take that IC there. Yep, perfect. So first things first, I've got to drop in the window. So I'll just give it a wee dust here. And get it the right way round with that raised notch at the right hand side. Drop it in. There we go. And now the acrylic panel and TFT. I'll just give that a dust off as well. There we go. And I'll drop that in. And the next thing, a little bit of this single-sided foam just on top of the TFT as I mentioned earlier. So I'll just take a bit off there. There we go. And I'll just position that. Right. And finally, let's bring in the board. To untangle it here, there we go. Bring the flat flex through. And I'll put in a couple of screws. I'll do that off camera because I need to get right over it to do that. And finally, let's just hook up the flat flex here. And there we go, that's it mounted up, all ready for a power up. So let's hit the power button and see what happens. Yes! It's working! Yes! It's working! Wow! And it looks great. You can see the acrylic panel, but because it's all black, it's not too bad. Up on the workbench there, you won't notice it. And the position of the text, including the enunciators, isn't too bad. More often than not, you'll be looking slightly down at a multimeter like this, unless you've got it mounted up high. So the text is slightly justified down to this bottom edge. But of course, that's just a case of repositioning that TFT with the Kapton tape if I do needed to move it up a little bit. And I'm really happy with that, so let's just extend the digits here. Yes, no problem. Just turn the power off again and reset it. And I've just realised why I wasn't getting the 4.7K when I measured it earlier with those two resistors on the back of the board. And that's because I do still actually have this one still paralleled up and running. And of course this one's got two resistors on it as well. And I think I can safely remove this wiring now from the main board. And there's another look at the back. You can see, like I've shown, it's extremely easy to fit. There's basically no soldering required at all within the unit apart from bypassing that series resistor. And if you look at the back of the blue pill, you will notice there's a couple of LEDs. The red one's basically power. The green one will flash in sync with the signals being sent from the main board. So if you hook it up and you're not getting any flashing green LED, then you'll know you're not getting any serial data. And I think the flat flex at this end of the board is sufficiently far away from the edge here, so the cover will go down on there without interfering with that flex. Now we'll make all the code available, including the source code and of course the hex file if you want to go in ahead and make your own, and I will provide instructions as well. They'll be linked in the video description down below. And of course the gerbers will be available as well. I do have a slight tweak to make. I just want to move the position of these holes on my board just to lift that board up just a small fraction because it's slightly too low. As you can see along the top here, I would rather it sat on that top edge, so I've just got to adjust that, but that'll all be taken care of. And before I put the cover on, I've got to put on this plate here, so I'll just offer that up. So there we go, there's it mounted above my 3245A and my R6581T, and of course just below my 6243. And we've got a trio here of TFT conversions, the 6243, the R6581T and now the 3457A. There's only this one here yet to do, but that's for another day. I would actually like to convert the 3245A to TFT, although the VFD is in pretty good shape. But if I can manage to convert this one to TFT, that will actually be fully compatible with the 3458A, which I think would be a good move. So if this video has helped, entertained or inspired you today, give it a like, drop a comment down below with your thoughts. I do read them all, and if you haven't already, subscribe so you never miss an upload. Turn on notifications too. Your support turns casual watchers into regulars and keeps the channel thriving. See you in the next one. Take care. But wait a minute. I've just been inside it again. As you'll have noticed in the last shots, the text height for the main text is a little bit shorter than what it was in my R6581T. So I went into software and increased the font height just to see if I could squeeze it in to this narrow TFT here. And lo and behold, it fits in and it looks even better. Perfect.